Afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap. I'm very excited about this one. I've been watching some of the stuff on the back end, and it's some great technology. But before we get started, we do have some few housekeeping items to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your question and answer tab right there on your interface and submit your question, and we'll try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so I encourage you to chat us your comments, suggestions, whatever you want to share with us, and we'll be more than happy to chat you back. And also at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is a new approach to testing OTT media and entertainment in telecom. This is going to be a great webinar. We have with us today is Gaurav Mathur, who is the COO of a company called HeadSpin, and he is joined by Ilya Dreister, who's on the back end. You can't see him, but he's VP of Customer Engineering at HeadSpin. He's going to be doing the demo. Gentlemen, thank you both so much for joining me today. Really appreciate it.
Well, thank you very much, Charlene, and good morning, good afternoon, and good evening to all of you. Thanks a lot for making the time out of your busy schedule to listen to us today and engage with us. A huge thanks to DevOps.com for hosting us, and a huge thanks to IBM Red Hat Marketplace for sponsoring this webinar. I'm going to spend just a couple of minutes giving you an overview of HeadSpin, and then I'm going to pass over to Ilya, who's going to take you through a product demo, a very exciting product on how you can actually test OTT and media entertainment, especially in the telco industry. So what's HeadSpin? So HeadSpin, we were born in the Silicon Valley in 2015 with the mission of helping clients perfect the end user experience of the digital applications, whether it's a browser-based application or it's a mobile-based application. And we're the first company that basically provides those unique machine learning insights to basically identify what could be the root causes of issues that potentially could degrade your customer experience, and what could be the actions that you could take to fix them. The way we do that is, first of all, by offering through our platform the ability to test on the edge. We've got a cloud device infrastructure which has got a different set of devices across more than 110 cities in the world. So you're effectively testing on the edge, as opposed to testing using emulators or simulators, or using perhaps a set of devices sitting in a warehouse in 1 or 2 locations. Secondly, we have got the ability, and that's through our unique machine learning algorithms, which can basically identify the root causes of what is degrading a user experience through any journey that they are undertaking on your application, and what could be causing that issue, and what could be the ways in which you can fix them. Now, we've worked extensively in the last 5 years with 80+ clients around the world, especially in the telco sector, the retail sector, the banking sector, the gaming sector, healthcare, and with government. And today, of course, we're going to focus on the telco industry and how we are bringing a very unique solution in which you are able to measure the quality of audio and video that you're able to broadcast through different types of devices. So if we move on to the next chart, I want to just very quickly show you some of our telco use cases and some of the clients. You can see the list of leading clients that we work with. So we basically help telcos monitor and optimize the 5G experience, to sort of measure the quality of the data, voice, and messaging services they can provide, how they can effectively continuously enhance their quality of experience frameworks. A lot of them also use us to check the compatibility of the devices before they are released. We have the ability to help them test on the go. So you could be driving or you could be walking through from one location to another, and you want to see what is the experience of a user who's perhaps streaming on YouTube or any other application on their mobile phones. We are able to provide that feature. What we'll be talking more in details will be how we are helping ensure or enhance the quality of streaming on OTT devices. We also do a lot of regression intelligence, which means that as you are building your products, you're able to do build-on-build test, regression testing. You're able to compare across different geos. So with that brief introduction about the company and what we do in the telcos, let me not waste any further time and hand over to Ilya, who will actually demonstrate our product and bring to life our unique and differentiated platform and its capabilities in the telco industry.
Thank you, Gaurav. Thank you very much. And thank you all for joining us today. We hope to have this exciting content for you all to consume. Now, this slide is very interesting. I only have one other slide before I go into a live demo of the product, but I'm really happy that Gaurav chose this particular slide because there's just so much going on with the edge and video streaming, right? There is a lot of different video streaming apps at this point, and then there's the telcos that provide the backend for streaming them. And so, in terms of points of failure, from both sides of the equation, there are now multiple points of failure, right? You could have a network problem, which may or may not be the carrier's fault. Could be some settings. It could be something that's in the app itself. And so, as an end user, as a consumer, I'm watching a lot of content on different streaming apps. And so when there is a freeze frame, right, when the image kind of stops for a few seconds, or if there's excessive buffering, I no longer have a very clear idea of is it the app, is it my device, is it my local Wi-Fi, or if I'm on 4G or 5G, is it that connection, right? So there's a lot of points of failure, and that's where HeadSpin really tries to address and give tools to the QA folks, to the development folks, and to the performance teams at these different companies, both on the telco side and also on the app itself. So to do this, how we provide that functionality is we start with a global device infrastructure, because with a global device infrastructure, our customers can test the apps that they provide to their customers or the network over which various apps are consumed by their customers. And they can do this using real carriers, using thousands of real actual devices all around the globe. And as you'll see in my presentation, we have developed some really cool technology to enable specifically testing of OTT media on the various networks, right? And the way we do this testing is usually through either manual testing or test automation and APIs. And the test automation piece is really important because, that's what enables you to plug it into a CI/CD pipeline and essentially create that set and forget mentality of, I always have a test suite, it always runs. So whether I'm testing a new network or I'm opening up a new location, or I'm adding to my edge, or you're the app creator and you're worried about new features or making sure that there are no regressions to existing functionality as you roll out a new web version or a new Android version or a new Chromecast app, Apple app, right? That's really enabled by this automatic testing. Now, testing in itself is great, especially if you're talking functional. Can I watch the video? Yes. But then you get into this whole performance section, and this is really where HeadSpin shines. By allowing you to test on real devices that are really connected to the networks which you care about, we're able to surface these issues that are beyond functional. So can I watch this video? Yes, but it took 20 seconds to load it, right? Can I do a search for my favorite TV show? Sure, but it took 30 seconds to do the search, as opposed to it took 10 seconds, right? So identifying these non-functional metrics like, yes, you can watch it, but it's really blurry. Yes, you can watch it, but it took 30 seconds to load. But there's a lot of buffering. There's a lot of freeze frames, right? All of those things are kind of the responsibility of the performance team overall. And we do this from the client side and provide that information of what's going on in the network or what's going on in the video feed so that decisions can be made. As Gaurav mentioned, it's all about this insights to actions, essentially identifying what's happening, and potentially why. And that's where our platform comes in. So the first thing I want to show you is, as we mentioned, we have over 100 locations worldwide, and we also support on-premise deployments, by the way. So a lot of vendors or a lot of apps and telcos will actually, take some HeadSpin devices and put them in their own lab, but then also leverage some HeadSpin devices in their target market, right? So if you are, a telco that supports a locality like, say, the US, right? We have a bunch of different devices and web browsers on, any network that you can think of, right? We can do it on T-Mobile, we can do it on Sprint, which is now T-Mobile. We can do it in Great Britain on, any of their carriers. We can do this in other locations, right? And these are different kinds of devices that we support on the platform. And those devices include the usual sort of cell phones and, tablets and iPads, but they also include OTT devices like the Amazon Fire Stick or the Apple TV. We can also do the new Google Chromecast. We can do Roku. We can do devices like the NVIDIA Shield, which is currently unplugged in my data center, but, that's another one. So the list is sort of infinite in terms of what kinds of devices you can have, just scrolling through a few. And each of these devices, you can essentially activate it and do a test. So, we are working with one of the major providers in Brazil. And for them, it's important to test in their local market. And so, when they have engineering center here in the US as well, those engineers can actually jump on a device. And again, it could be a phone, it could be OTT, and they can actually use it, right? So we can pull up a web browser, or we can pull up a YouTube app, or even we could even navigate to the YouTube app, and we can basically, watch some content, right? So this is something we can do. We can also pick a different device, say this Pixel 4 in, Mountain View, and we can look at content on a Pixel 4, right? We can either open the app or, again, just go to YouTube and do it that way. And so you could basically watch video content across different devices or different surfaces and basically do testing. Now, these are two devices. Okay, that's interesting, right? We can also talk about doing this across, say, a Fire Stick or an Apple TV or a Roku. So I can show you, this is what it might look like if you are a OTT interested customer, where you have Apple TV 4K and you have Amazon Fire Sticks and you have them in, Sweden and Great Britain and the US. And so all of these can also be directly controlled or viewed from the system. So, with a Fire Stick, we can pull up a Fire Stick and we can basically, perform some testing on it. We can actually go to, say, the YouTube app, just like I was doing on those other devices, and activate it and, watch some content. And everything that I'm showing you in the user interface, we can do using automation. And that comes back to, setting up an automated pipeline so that you can constantly watch these videos. Now, in this case, we can support Appium or Selenium for web browsers, but really we're kind of agnostic as to the types of frameworks or testing that can be used. And of course, the other part of this is we can also capture the stream as it's running, and this is where we get into the interesting analytics. So, as you see right now, I'm basically recording what HeadSpin calls a session from this Fire TV, and it's actually going through here. And so if I say I return to the home screen, for example, and I want to do a search maybe for something else, right? Or switch a users or go into settings, these are all things that we can do. We can also look at the delay. So when I stop this recording and I look at a session, this is where you get some of that technology that I mentioned earlier in terms of being able to identify video content and video issues in the stream. So whenever you capture a session on HeadSpin device, you could capture a video session. This also applies to various applications, but essentially, this session was captured live, and now it's going to take a couple of minutes to analyze in the background, and then I'll be able to show you some of the other indicators. But as you can see, we've captured a complete video record of what was happening on the device screen. Right, for this, in this case, a Fire Stick. Here's my video metrics coming in. So I get blurriness and brightness and colorfulness and page content and frame rates. So these are being populated. And then there's one more I'm waiting on, which is essentially our mean opinion score. And that's a reference-free MOS that we've developed in-house. There's a great blog post explaining it. But it's awesome because you don't need to provide a reference video. You can essentially use this for live video or any kind of video. And, when you do this at scale, you can monitor videos and identify issues with the quality of the video. As you saw, we have blockiness and blurriness. So there's, these different indicators that are happening. And then you can aggregate that data and report on it. And, also in this case, it's an Android type device. So there's some logs that we can tie into. On the Apple side, we can tie into the, Apple logs. So in many cases, we can tie directly into the device logs here. And of course, for a test product, we do allow things like, screenshots and access to the logs, access to the file system, some other capabilities here. So that's all part of the platform. So similarly, if you want to look at an Apple TV, and this is an Apple TV 4K in Sweden, and bear in mind that I personally am in the Boston area in Mass, in the US. So a device in Sweden can be operated by a remote person like me without any issues. And, again, we can navigate, we can go start a stream and capture it. So something that is interesting is, of course, being able to aggregate this. So I showed you one particular session that had some data, but, here's what it might look like at scale. And again, this really comes into play when you think about it from a telco provider. So we do work with a lot of telcos in different countries, and a lot of them are essentially benchmarking their service level based on popular video apps. So YouTube is a good one, right? Netflix, Amazon, and so on. There's also, of course, local streaming apps that are specific to a market, right? Japan, US, Sweden, etc. So this is what it looks like when you do testing on the YouTube app on multiple devices, Android and iOS in this case, across different cities in Australia on 3 different carrier networks. And because these are all real devices, these are all real numbers. So this is your typical pass-fail rate. That's great, very important. But beyond pass-fail, you can get into non-functional metrics like the playback time or the search time that's populating in here in a moment. And then you get into the video quality score, right? So we talked about our video MOS algorithm. So what this allows me to see is what is the average video quality for the sample stream that we're constantly running on these devices using the YouTube app, right? These are the search times that we talked about earlier. So as you can see, there's sort of an average, and then you get these spikes at specific locations. And of course, you can then pull up a session and dig into it in more detail and see if it was a network issue or a device issue or maybe something in the app. So blockiness, blurriness, right? All the different indicators, we can essentially put them into a dashboard. And so this is kind of the vision where you can have a, from a telco point of view, you can run the same YouTube clip over and over again and basically make sure that the screen isn't blurry, make sure that the bit rate is correct, make sure that the correct servers are being used for it, etc. So this is kind of putting it all together and being able to do this at scale. And another thing that's interesting, of course, is being able to do this on the go, because a lot of people consume media on the go, right? On a bus, on a train. And so this is an example of using HeadSpin's physical devices in a vehicle as it travels, again, on the coast of Australia, right? So we can essentially look at indicators, everything from a simple speed test to, again, playing that YouTube or playing, a Netflix or Amazon clips and going through it. And so that's an element that HeadSpin can enable. So if you want to do testing in a particular location, if you want to do testing in your own lab, if you want to do testing on a moving vehicle, these are all scenarios that are really relevant to both the telco side and the actual consumer app side. Now, another interesting thing that we ran into, and this is really why this particular webinar is talking about, new ways of doing this. One of the major problems with capturing data about a streaming app is DRM. So here's an example of an application that includes that video quality mean opinion score that I mentioned earlier. And this is like a 25-minute clip of the NBA parade a couple of years ago. And in this case, it's on an Android device. And as you can see, it's the same indicators, plus you can look at the CPU and memory usage of that particular device. Now, we can also capture network results of what's going on in the network layer for almost all of these systems, if not all. And these network results will allow us to capture, the underlying data, so we can extract from that things like bit rate, what are the CNIs, what are the appropriate servers that are actually serving the content, and then we can make decisions based on that as well. But the other piece of the capability are these sort of orange bars, right? So our platform automatically identifies issues in the stream. And so one type of issue could be poor video quality based on our mean opinion score. And it shows that, hey, over here, the video quality gets really bright and out of sort of washed out, compared to later on. But again, it's a mean opinion score, right? So if you have more or less of these indications, then you can decide that the video is better or worse. But then you can also look at specific things. For example, loading animations in our world basically means we're detecting a spinner and we're waiting for some content. So if this happens during video playback, then that would be a buffering event. If it happens during the normal sort of app execution like here, then it's basically showing an app level issue. And so there's a lot of other issues that we could show over here. This one doesn't have it, but we can find repeated black frames, for example, right? So we can find not just black frames, but if an image is actually frozen and frames are being repeated for a period of time, we can flag that. If there's buffering, then this loading animation can pick that up. If there are other issues in the stream, we can detect them as well. So, this does allow you to, once again, kind of run this at scale in a CI pipeline, and then go back to something like this, Aggregated, and say, hey, where are my spikes? Where do I need to dig in further and pull up one of these sessions and actually, understand what's happening, right? And that's something that our platform can do. But one of the things we started running into is, of course, DRM. So if you'll notice I use the YouTube example, right? Because it's easy. They don't have DRM on their videos. But when you're typically trying to capture a video from a platform that has DRM protected content, there's no way to do it without either breaking the DRM or having a lot of agreements with not only the studio or the content creator, but also the technology partner and the encryption stack and everything else. And so there's a different way that HeadSpin came up with, and we call it actually an AV box. So what we've created is essentially a standard data center rack mounted box that is fully darkened and soundproofed. And inside, you can set up a system of whatever you want to test. So for example, I want to show you what it looks like when you're using the Roku. And the Roku is entirely DRM protected. So, the Roku appears on our platform through this AV box, where essentially we have a 15-inch screen, a 4K display that is showing the Roku, right? The Roku is actually connected to the display via a HDMI cable. And then we have a second device, which we can use either for manual or automated testing to control the Roku. So here I can go in here and I can pull up a stream. Now, what you don't see is there's a third device here that's actually the camera device. And the camera device is actually what you're looking at. So over here on the right-hand side, what we're actually looking at is not the real Roku screen. It's actually a camera showing us the Roku. And so now we can go to DRM protected content, for example, Discovery Plus. And we can actually see it. We can watch the movie. And the best part, of course, is we can also capture a session here. And that will, once again, allow us to navigate through the video and identify issues. Now, I guess this box for the demo is not configured with a Discovery Plus account, but let's see if we have something like a Netflix account, maybe. And if not, anyway, so the Roku is, I need to sign in. So the Roku is essentially DRM protected right from the start, right? So, what this platform allows us to do, though, is it allows us to take something like a Roku or a Chromecast or a Fire Stick or really anything that has an HDMI feed, including, a set-top box, right? Or an Android TV box or some other kind of device that plugs into the HDMI port. And we can essentially put a camera on it and then capture it. And it plugs seamlessly into our platform. You can still use automation. You can still capture the results. And you can basically capture the video. And we haven't talked about audio, but audio is another part of the platform. So, with this setup, whether it's an Android phone or a tablet or something like a Roku, you can put this into our AV boxes and you can have this. And so one of the large US-based streaming providers is currently rolling out a set of these AV boxes. Another is a telco in Japan that has video streaming, and they're rolling out a bunch of these boxes. And so with these boxes, you can not only attach different kinds of devices to the platform, but you can also observe the same on, standard devices. So an Android phone or an iOS device like an iPad or iPad mini, all of those can be inside the AV box, and the camera setup allows us to capture the video. And then our standard platform capabilities includes the ability to essentially, score the video, identify problems with it as we're doing over here, and to do this at scale. So this is what we mean when we say that we have this new approach to, OTT media testing. And so just earlier today, I was speaking with someone who's putting together the performance team at another one of these, old school studios that have now switched to streaming as a revenue stream. And of course, it's very important for that revenue stream to, grow as there are more and more cord cutters. And that's where we come in. So, just to give some very specific needs, certainly testing on a lot of devices. I mean, I think everybody at this point in telco, in streaming, and traditional, legacy media, everybody's familiar with the concept of, hey, you have to create your own lab, and you have all these devices and televisions and, Rokus and everything in there. And then you need to test it, and you need to control it, and you need to have people sitting there and watch the streams. So all of this can now end up on this platform. First, we can provide on-premise devices. In fact, if you already have all these devices in your premises, right, you can simply plug them into the HeadSpin infrastructure, and that's a very seamless on-premise solution. And then in addition to that, you can actually attach other devices that are provided by the HeadSpin platform and hosted, and hosted by our data centers. So just to give you a sense, in one interface, I can see devices across different parts of the world, but these Boston devices here are actually in my home office. So for me, the Boston set of devices are actually my on-prem solution, but they commingle with devices that are in the cloud. So similarly with telcos, typically there is an existing lab and they do have existing devices, and that's fine. You can add them into the HeadSpin portal while also leveraging other devices, either because you may not have them in-house or because you want different locations. So a streaming provider that's big in the US and now wants to expand to, say, Mexico, or they want to expand to Canada, or they want to expand to, Brazil, right? The UAE, in Europe somewhere, India, of course, South Korea, et cetera. These are all places where we have data centers. And so you can take your existing lab and host it on HeadSpin. You can also get access to devices that are in different parts of the world. And those devices are, of course, these different, audio video type devices, along with the traditional phones and tablets. So by putting all that on the HeadSpin platform, not only can you get your functional testing done the same way you do it today, but you can also extract all of this new non-functional information, including the quality of the video, identifying problems with things like freeze frames or, excessive buffering. You can get things like your average bit rate for the video. You can correlate the average bit rate as you vary it, and see how it correlates to the quality of the video. That's another use case that's very popular with telcos. And this really applies to all kinds of, video streaming. So certainly we've been focused on, Netflix and, Hulu, et cetera. But there are, other platforms like Facebook will do a lot of video. LinkedIn is doing video, and we're helping them, right? So there are a lot of video content coming up to not just traditional sort of media companies, but also, new age apps and kind of established apps that are doing more with video content sharing and streaming. And of course, it all comes back to being able to test it on the edge, which in our case means these real devices. In fact, one of the telcos that is rolling out, home internet through 5G is literally putting our boxes inside, rented apartments where they can now test a real user experience, but they can test it in pre-production. And that's a very important part of this, slide deck that we had over here, where if you look at all these different scenarios, you may want to deal with data and voice. We haven't even talked about this, but, making a phone call, recording the audio and comparing it against the expected audio is something that can be done in the platform. Just yesterday, I was setting up a test where we were joining 4 people in the US and India on a call using one of the very popular, up and coming AV platforms for telecommunications. So you can do video call testing across different locations, with or without this AV box concept of ours. Obviously, drive and walk tests that we talked about, right? And all of this comes down to pre-release capabilities. So when you think about this, the test automation and integration into CI/CD, that's really what allows you to do this at scale, do this on real devices, do this on the real edge, but do it for the pre-production stuff, right? And that's what HeadSpin delivers. So with that, I'd love to stop and ask for any questions from the audience. We would obviously love to answer any of your questions and have a discussion going forward.
Yeah, great. So we have gotten some questions in so far, but there's plenty of time. If you have a question for Ilya or for Gaurav, go ahead and use that question and answer tab. And let's go ahead and dive into the questions we have right now. I'm going to take myself off screen because I don't like looking at myself on screen. So I'll just answer the questions here. Question number one, this is from Paul. He asked, how does HeadSpin test 5G-R, 5G ready content, such as VR, AR, 4K streaming video, etc.?
Yeah, that's a great question. So I'll do it from the tail end first, right? So 4K streaming video, that's very simple. That's literally what I was just showing. So we can test on real 4K screens, real 4K content, and that content could be coming from anything, right? You can put in a PlayStation or an Xbox into our AV boxes. You can put in a cable set-top box. You could put in a Roku, as you saw, an Apple 4K. So anything in terms of streaming and video can go in there. And again, as I mentioned, it depends on the scenario. So the telco provider I mentioned earlier is literally testing a 5G home modem, if you will. And so all of these different devices can simply get their Wi-Fi from that 5G modem. Obviously, with handsets that actually are 5G ready, like the Galaxy S20, for example, or the iPhone 12, you can do native testing on those and just have a SIM card or a contract with, your or other telco provider, right? So that's easy enough. VR AR is very interesting. So in terms of AR, one of the capabilities of our platform is to actually let you hold your actual device in your hand while also being on the HeadSpin platform. So I could literally plug in my personal Android device into my computer here and then bring it onto the HeadSpin platform and actually record a session. So if I wanted to play the Pokemon Go game, for example, and I wanted to walk around, my office and capture Pokemon, I could be recording a session on that. So AR is a very interesting one. For VR, we've actually gotten the Oculus Rift onto our platform. So that is something that we've done with other, VR devices. That's a little more interesting. So we haven't explored a real generic 2-camera system to kind of create 3D stereoscopic images, but certainly we can get some of these things on the platform and then essentially, treat them as any device on the HeadSpin platform, capture a session and be able to see, what was on the display and what are some of the parameters coming off the device. So VR AR is really in its infancy from the testing and from, sort of cloud testing point of view. And we're really excited to work with some partners in that space. 5G, on the other hand, has now been around and more towers are popping up. So it becomes more and more practical for us to set up these remote locations with real 5G devices, either, Android devices, iOS devices, or, like I mentioned, kind of hotspots or just home solutions, and then test on those. Does that answer the question, Paul? And feel free to, ask any follow-ups.
Yeah, please, Paul, if you've got more questions or more questions related to your first question, just go ahead and use either the chat or the question and answer tab. Anybody else who has a question, please feel free to do that as well. Next question here, does HeadSpin support Roku devices?
Yes, it does. So Roku was an interesting type of device. We actually worked with them a little bit on creating an Appium driver for it. And so, yes, Roku is a device that HeadSpin does support. As I showed earlier, we do it through the AV box so that we can plug it into a screen and actually capture the video that way. But again, you can automate it with Appium. You can automate it with other solutions, including some of our partners. And we'd be more than happy to discuss that use case with anyone that would like to test on Roku devices.
Excellent. All right. Great. Let's see if we have other questions here. No. Okay, all right, great. So Paul said that did address his question. So
Awesome.
yeah, great. Okay, next question. What about DRM content? Does HeadSpin work with that, or is it only unencrypted video?
Yeah, great question. DRM is really challenging in this industry, right? So our AV Box solution allows us, to work with DRM content in a legal way, of course, with fair use, and specifically for testing, that's what we're able to do. So now folks are able to test on, any of these OTT devices that we keep talking about, and also look at, DRM protected content, as long as, of course, they own those rights. For testing purposes. So yes, that is a use case that is very common. We get asked about it all the time. So I'm happy to say the answer is yes.
All right, great. So still plenty of time for questions, guys. I have one more question in here. So if you do have a question for Ilya or for Gaurav, go ahead and use that question and answer tab and get it on in. Here's a question for you, Ilya. Can HeadSpin help me identify video artifacts and problems such as glitches, freeze frames, buffering, etc.?
Yeah, I mean that's a big part of what HeadSpin does, right? We have these machine learning algorithms that are part of our data sciences platform. So whenever we capture a session, as you saw earlier, we analyze that session and we look at things like the video quality, MOS, and blurriness, blockiness, and some of the other parameters. But in addition to that, we can also pick out three types of things. One is, as I mentioned, loading animation, which basically is a spinner that pops up. And again, if that happens during video, then of course that's buffering. The other thing we can do is look at frames that are being repeated, right? So an image that is stuttering or an image that is sort of frozen for some period of time. We can also identify screens which have very little content. So essentially an all black screen. And again, that might be part of the video, of course, but we can flag those for easy review for a person to look at. And then in addition to that, we're also, we're continuing to build out our ML algorithms to identify more kinds of issues with video. So, we can already identify low frame rate areas or areas of poor quality, but we continue to expand that capability and identify more problems. Another thing that we do, which I actually forgot to mention in the presentation, is we can use this technology or this application of recognition of frames to identify how long it takes to transition from something to something, right? How long does it take to start playing the video, or how long does it take from search to play? And the other thing we can do is pick up watermarks. So we can plug in image recognition into the equation. And so, for one particular sports live streaming vendor in the UK, I believe, we were actually able to implement watermark detection so that they can confirm that, whenever their live content is on the screen, there is a corresponding watermark, which of course could be anywhere on the screen, and it comes in different shapes and sizes. But that is another possibility with the platform. So if anybody has interest in, picking out different kinds of issues with video, or you just want to kind of get away from having a room full of people staring at the screen looking for a blurry or failure of some kind, we can help you out with that. I would love to talk.
All right, great. Well, those are all the questions that we've gotten in so far. I'm going to leave the question and answer tab open for a few minutes more to see if we get any more questions in. And while we are waiting, just a quick reminder to the audience that today's event is being recorded. So if you missed any or all of the presentation, you will have the opportunity to access it again and watch the whole thing. Following today's webinar, we are going to be sending out an email that contains the link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there as well. Just go to devops.com/webinars and look in the on-demand section. It should be right there waiting for you. Okay, still no new questions. So while we're waiting, I'm going to go ahead and do the drawing for the 4 $25 Amazon gift cards. Our winners today are Linda G. Congratulations, Linda. Our next winner is John P. Congratulations, John. Third winner is Rod M. Congratulations, Rod. And our fourth winner is Jack Okay, congratulations, Jack. We'll be following up with all 4 of you offline by email to get your Amazon gift card over to you. So please check your inbox. And if you don't see anything there, please check your spam folder. Well, I think that's it for question and answer. So I do want to thank everybody who did submit questions. Gosh, there were some good ones there. So, Ilya, I like to think that fewer questions means that you did an amazing job with your presentation, and everybody knows everything there is to know about your platform now. So. Thank you very, very much. Great. It was a great presentation. So I guess at this point, I'm going to go ahead and shut things down a little early, give everybody 20 minutes back in their day. Gaurav and Ilya, both thank you for your time and your expertise. Good stuff, great technology. Thanks for showing it to us.
Thank you, everybody, for attending.
Well, thank you very much. It's been a pleasure.
Okay. All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.